welcome to Math 120, Section 6.4's lecture. So to begin with today, on your handout, you're going to notice that I have given you something that is just a review from the world of functions. So I have a function, f of x equals 3 to the x, happens to be an exponential function that we talked about last time in Section 6.3. And as you look at the mapping here, I have the domain of f on the left-hand side and the range of f on the right-hand side. We have the fact that if we plug in an x value of 0 into this function f, we're going to get 3 to the 0 power. If we plug in a 1, we're going to get 3 to the first. If we plug in a 2, we're going to get 3 squared. Now, at this point then, what I want to do is jump forward from just function world to something that we've talked about more recently, the idea of an inverse function. So remember that an inverse function undoes what the original function does. So the inverse function would come in and take this 3 to the 0 power in the range of f and move it back to the 0 over in the domain of f. 3 to the first would get mapped back to 1, 3 to the second would get mapped back to 2, and that's all happening with this new function called f inverse. So the first question we have is there going to be an f inverse for an exponential function? And the answer is yes. If you think back to section 6.3, one of the things that we knew about the graph of f of x equals 3 to the x was that the function was 1 to 1. It passed the horizontal line test. So if you need to think about it, you can go ahead and think about it just a general graph. So that's the general graph of an exponential, and it passes the horizontal line test, so it's 1 to 1. And because it's 1 to 1, that means then that yes, this function f will have an inverse. So there's a function f out there, and there's a function f inverse out there that will undo whatever f does. So once we realize that f inverse does exist, we can think about how to write this down in functional notation. So f inverse takes an input value of 3 to the 0 power, and it takes it back to an output value of 0. Well, 3 to the first is the input value. The output value for the f inverse function is 1. 3 to the second is the input value, and then 2 is the output value associated with f inverse. So as you look at this then, what I want you to do is notice a pattern. If you need to pause the video to think about the pattern for a moment, go ahead and do that. So f inverse takes 3 to the 0 power, and it gives us back a 0. F inverse takes a 3 to the first power and gives us back a 1. F inverse takes a 3 to the second power and gives us back a 2. So this f inverse function always returns the exponent on our 3. So if that's the generalization in words, I can find f inverse of things that aren't even on this mapping. If I have the f inverse of 3 to the 4th power, I know that f inverse always gives me back the exponent on the 3. Well, the exponent on the 3 here is 4. So now that we know that this f inverse function exists and the fact that it simply gives you back exponents, I want to introduce you to some notation. This function, f inverse, actually has a special name. F inverse of x is called log base 3 of x. So as you look at this problem then, I can take each one of these statements that I wrote in terms of f inverse notation and just write it as log base 3 notation instead. So instead of calling this f inverse of 3 to the 0, I can call this log base 3 of 3 to the 0. And I know that my answer has to be 0. So log base 3 of 3 to the 0 is 0. Well, let's do the same thing for the next one. Log base 3 of 3 to the first is equal to 1. And the final one, log base 3 of 3 squared, is going to be 2. So as you look at this then, once again, what I want you to notice is that there's a pattern emerging here. Log base 3 is simply asking you, what is the power on your 3? So log base 3 of 3 to the 0, the exponent is 0, so you write down 0. What's log base 3 of 3 to the first? The exponent on that 3 is 1, so log base 3 of 3 to the first is 1. And finally, log base 3 of 3 squared, the power on that 3 is a 2, so log base 3 of 3 squared is 2. So whenever you're looking at this section and you're wondering, what is this log thing all about? It's always asking you, what is the power, and in this case, on your 3. So this function that we started with was f of x equals 3 to the x, and the related inverse function was log base 3. Well, if I changed my original function here, and I have g of x is equal to 7 to the x, then the related inverse would be g inverse over here, and it would be log base 7 of x. Well, log base 3 was always asking you about the exponent on the 3. Log base 7 would always be asking you about the exponent on the 7. In the same way, I could have 9 to the x and log base 9 of x. Log base 9 would be asking about the powers on the 9. So we can take this idea and generalize it to any variable that we want. So instead of saying log base 7 of x, I could talk about log base a of x. Now I do have to be kind of careful when I do that because a has to be greater than 0 and a can't be 1. So you'll notice that I've given you a definition for log base a of x on your handout. Go ahead and read that definition, and then we'll go ahead and start into example 1.